Hmm. Mm-hmm. Hello, hello. If you are here, I'm here. Uh, Pretty easy week math-wise. I was figuring this is going to be a little bit of a shorter stream. See if anybody shows up. I got some general practice here. And then I was going to talk about the stuff this week. And then next week is spring break, or called spring break, or whatever. So we aren't doing anything during that week. There's going to be no homework assigned. There's going to be no new stuff. But then when we come back from that, there's going to be a lot of new stuff. And it's actually going to be graded, and we're allowed to like go forward at full speed and stuff. So things are about to change. The way this is structured, we'll be going slightly faster-ish than we have been going for the past 3 or 4 weeks. Um, which, if you've been around, is pretty slow. We did 3 total new sections over 3 or 4 weeks. But it's going to be a little more starting next, uh, next week, after next week. Hello, Vachin. These are Algebra 1 questions, so these will be a lot easier than last time you showed up to the stream, because there was a lot of calculus on the screen. Screen? Bleh. Hello, hello. Okay, 5th period checking in with Alex and Kaya. Hello, hello. Hey, Dawn. If you missed my opening part, next week's spring break, so we're not doing anything, whatever that means. And then the following week, we will be back in full force, probably with a slightly different schedule. They're still hammering out what times math teachers are going to be able to teach. Uh, there's some lobbying going on right now for that sort of thing. And I'll be doing things during those times when that happens. So next week we do not have the stream. We don't have any videos. We don't have any homeworks because it's spring break. Because that still means something. Uh, so yeah, next week is a week off. Um, it's very confusing. But I would like you trying out the 5 questions on the screen. 1, 2, 3, 4, 2. That's pretty good. Good and professional. Haven't changed things up since the classroom. Uh, these are a mix of things that we did this week and last week, um, with basically 1 and 4 being things we looked at this week, 2 being things we looked at a couple weeks ago, and 3 being something we looked at last week. Haven't units been taken out? Kind of. We're not going to do the stats unit at the end of the year, probably. But in Algebra 1, we actually have a lot of flex time. We aren't going to be taking out a ton of stuff. But yes, a little bit. Uh, the good news is, in both Calculus and Algebra 1, the two classes I teach, there is. We were ahead in both of them. So we're not really behind, even though we've missed a couple weeks, assuming people have been doing things. How do you feel about school closing? It was probably a good idea. uh, so, yeah. Um, Washington State has messed up less than most other states as far as death toll goes and impact on the healthcare system and virus growth and all that. So we did things more right here apparently than in other places. So that's good. Uh, Shout out to the Washington people. Trying to figure out that first one. Oh, I got it. If you were here last week, you should know how to do 3. We definitely did 3. 2 requires you to think back a minute. And if you've done any of the stuff or watched any of the videos this week, 4 should be gravy. And 1 should be a little harder. But more reviewy? We'll see. And yes, watching. The next time you could be in my class or have stuff will be in AP Calc. And the next time I stream will be in AP Calc. Oh, you skipped the first one, the rest you got. Hey, that's not too bad. How are other people doing? Feel free to shoot a done in when you're done, or if you're ready to see some solutions or whatever. I woke up before 11 today, so I'm pretty proud of myself. Yesterday I woke up at 11:45 and there was a math meeting at 11 that they had sent out emails for at 8:30. So my sleep schedule got me in a little bit of trouble. Oh well. Keeping it classy. And yeah, I guess unless you're in Hug, you guys are lucky because no AP tests. Because all the people in AP classes still have AP tests. They're just a lot shorter this year. Uh, Although for many of you who are in those classes, a 45-minute AP test is actually pretty sweet. Don, I'll give you a hint for question 1. Common denominators is a pretty good way to do it. Or you can multiply by something that gets rid of all the denominators. Lots of different plays there. Yeah, FRQs are the hardest in calculus too, for most people. So the sentiment is similar among those students. Yeah, Alex, you got 3 right for sure. Do 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 do. Netflix until 6:30. Hopefully you're watching Community. That just came out on Netflix. My wife and I are watching that right now. It's pretty great. Uh, oh, watching that does look correctly factored there. For 2. Surprised nobody put 4 in, because I think 4 is the easiest one. um, that would be one of my favorite to write in and spoil for everyone. Good job, Alex and Justine. Good spoiling there. Vachin, honestly, they probably would ship them soon. I think fewer people are buying those things. I need to upgrade my PC too. My lack of RAM is starting to kill me. I bought 16 and the 16 went bad, and so now I had to put my 8 back in, and 8 is not enough. So feels bad. Uh, yes, Don. 0, comma -4 is probably the best way of writing that answer. -4 is the y-intercept, though, so like it kind of depends on how it's asked. Usually they want a coordinates point like you, but saying -4 is also correctly the point at which it goes through the y-axis. So I think they're both right, both what you said and what Alex and Justine said. So I think I'm going to jump in and do question 1 from the get-go here, since we have spoiled 2 through 4 already. So the common denominator of 2, 3, and 5 is actually 30. So I just need to rewrite all of these such that they have a denominator of 30. And 2 times what is 30? It's 15. So for this one, I'd multiply by 15 on top and bottom. For this one here, I'd multiply by 10 on top and bottom. And this one here, to get to 30, I'd multiply by 6 on top and bottom. Again, the goal is to get all the bottoms to be 30. 5 times 15 is 75. 10x is the top in this one. And 6x is the top in this one. So all I did in that step was rewrite, basically like unsimplify, so that all the denominators are 30. Now that all the denominators are 30, we can yoink them, like so. Multiply by 30 on both sides. And you get 75 equals 16x. 10x plus 6x. And then you just divide by 16, and you get 75 over 16 equals x. Or 4 and 11/16, which is, 4.6875. For the second one, quite a few people figured this out. The deterministic way of finding this would be 2 times 6 is 12. What adds to 12 to 7 and multiplies to 12 is 3 and 4. And then, bam, box acquired. I put my 2x squared up here and my 6 here from the original problem. And then I build the 7x by using 3x and 4x. And then you just put the sides on so it works. So 2x goes into both of these two terms. 2x times x would give me 2x squared. And you get the plus 3 and the plus 2, which actually perfectly matches with both what Vachin and Alex put in chat there. So answer being x plus 2 times 2x plus 3. 3 is pretty easy if you know the formula that you plug this into, which is y equals your vertical stretch times parentheses x minus x1, but because it's already negative, we do a plus 2, squared plus 5. And all we did here, if you don't understand, is plug stuff in. So this is supposed to look like this. That's a quadratic formula equation in vertex form. And we just put negative 2 in for h, 5 in for k, and 7 in for a. And we're done. That's it. That's the end. Just plug in. And 4 is also just literally read the question. That's the y-intercept. If it's not in vertex form, the number at the end is the y-intercept. If this had been y equals negative x squared minus 4, whoops, I meant negative x minus 4 squared, like this, negative 4 would not be the y-intercept. The y-intercept here, we'd actually have to expand this out to turn it into standard form, which we use basically only to find the y-intercept. So you actually have to expand this out. And you get something like negative x squared plus 8x minus 16, and minus 16 would be the y-intercept. And so you'd have to go through that process. Okay. On the bottom one, since this happened recently, since I got this computer from the district, how many stylus batteries have I gone through? Let's see if there are any answers to this in chat. Once again, I tried to pick a question that was hard to look up, because I don't know that this is possible to look up, unless you can see my Amazon search history. Because quadruple A batteries are not a very common buy for me. Like, I didn't even know they existed before this. Thank you, Vachin, for raising the level of maturity. And it looks like our closest guess is probably going to go to our first guess, whoever Birdo is. I believe I've gone through 3 of them. This is the third. This is the 4th one now in my pen, which means I've gone through 3 of them. So yeah, I had to. Oh, Caden. Yeah, not good job, Caden. It turns out these batteries last a lot longer than you think they would, or maybe I just don't use my Surface that much. Who knows? Alright, so yeah, I wanted to review what is happening next week. So the spring break schedule or whatever. There are no videos, homework streams, because I'm not supposed to assign anything during spring break. When we get back, assignments will be graded again, so I'm going to be creating a new grade category for that. That's going to be part of the grade and adjusting percentages for the semester and blah, blah, blah. And it looks like we're still going to be on a pass and no credit system, but there's a possibility that core classes will still assign letter grades. So this is the general plan for next week, and the plan afterwards is, if you missed the opening part of the stream where I was rambling to myself, the way it's going to look is something like Monday, Tuesday, Wednesday, Thursday, Friday, like this. There are going to be blocks for like English and blocks for math and blocks for other departments, science, that are going to be like certain times of the day. And that's when teachers are going, like me who stream, are going to be streaming, is during those blocks. So I don't know what those look like yet because there's still some lobbying and arguing and fighting and whatever about how things actually look. But this is the general plan. Is no credit just a nail, a fail? It's a fail that doesn't affect your GPA. So it's like a fail that isn't an F. It's like you never took the class. So yeah, no credit, the NC thing, is never took the class. So it does not affect your GPA, but it does not give you credit. So it's a little different than an F. uh, for most of you, it's probably about the same in value. Both an F and a no credit sucks because you got to retake the class or make it up or something like that. So it's a very weird thing. Um, if you've been involved at all doing things, if you're doing most of the homework, there's basically just no question you're going to be a pass, because that's most of what we're going to be assessing down the last stretch here. It's really the people who had poor grades coming into this break and do nothing. Those people will be the potential no credit people. Does that mean everyone that passes has a 4.0? No. Going into next year, you are going to have, assuming we are all pass and no credit. Um, Going into next year, you're just going to have your GPA from first semester. You're going to get no GPA from second semester. Uh, does pass go into your GPA? No. Also no. You just get credit for the class. So it's a little weird. Yeah. We don't pass fail that often, and we're pass failing with every kid at the school in every class. So this is this is what you do your sophomore, junior, and senior year is going to matter a lot more than it has for previous freshmen, because only half of your grades are going to actually affect your grade average this freshman year. So that's weird. Isn't a pass just everything above 60%? Kind of. It's actually a little more flexible than that. So that it's no longer a very rigid boundary, and it's going to be more complicated than that. How about the first part of second semester GPA? If we go to pass fail, Alex, the first part of second semester is irrelevant, and that grade doesn't matter at all. If we decide to keep grades, it does matter, but I think that's the lower likelihood scenario. So the only thing it impacts right now, your grade coming into this, is how much work I need you to do in the second part in order to receive a pass. Well, when is school done? I think the end of June is when we'll probably be done. I think we're probably going to go all the way till that point. They said they will not go past the end of June, but that's still a discussion, so not entirely clear. No, every time I get these informations, I'm fascinated because they are making up new stuff every day. What about grade bumps for AP tests? Yeah, your grade bumps are all just gonna go to first semester, dude. So you're gonna be chilling. uh, okay, so the other thing, whoops, that was not the right button. Um, I wanted to do was just open up for questions this time because this week was pretty easy as far as the material went. Uh, do people want to see more like fractioning types of questions, more factoring types of questions? What kind of stuff are people curious about seeing? I'm open slating right now because we are about to go into break. I didn't have a ton planned. We're going to be doing chapter 9 when we get back, so something kind of new. It's more quadratic stuff, but it's more of the solving kind, which is why we started with the fractions. Factoring. I didn't focus on anything this week. Okay. So let's factor something. What do I want to factor? Let's do... Wait. Is this too evil for even me to feel sad and stuff? Yeah, that's too evil. Too evil. Let's do this. And then let's do... Haha. Let's do that. And then I'll do fractions after this. So, could you show how to find the axis of symmetry and find the vertex? Yes. Sweet. Then I have 3 types of questions I want to do. Okay. So a little review of factoring. No GCF comes out of any of these, so we can't start by taking out a greatest common factor. Our starting play is to do A times C is 15. 3 times 5. Think about the multiples of 15. 1 and 15. Those don't add to 8. 3 and 5. Hey, those add to 8. We build our box. We put the 3x squared up here. We put the 5 down here. But the way we build the 8x, which is what goes in these 2 boxes, is by putting in these numbers that add to 8. 3x and 5x. And then once you have these, all you do is you have to pick your sides correctly such that you're factored. So 3x goes into both 3x squared and 3x, and x goes on this side to get 3x squared. X times what is 5x? That's a plus 5. Let me get rid of those. 3x times what is 3x? Plus 1. And booyah, factored. 3x plus 5, x plus 1. So this is a review of kind of the harder kinds of factoring. There were definitely easier kinds of factoring that we did. Just to do one more factoring example before we bail on this. Whoops, I want to erase everything. Okay, is something like this, 4x squared minus 36. This time there is a greatest common factor. It's 4. Goes into both of these. So we can take a 4 out. And we get x squared minus 9. And then we can factor x squared minus 9 because it's a difference of squares. There's no middle term. So we know it's just going to be the square root of this. So like x plus 3 and x minus 3. If you don't remember how that trick works, basically, if x squared goes up here and negative 9 goes down here, x and x have to multiply to be x squared. And we want these 2 terms to add to be 0. And that's why we pick a plus 3 and a negative 3, because we're going to get a 3x, a negative 3x, and a positive 3x, which cancel out to give me 0. And that gives me no middle term and is fully factored. Okay. Second thing was fractions. So starting at the beginning of the year, we did some questions like this. And this was kind of the first type of fractiony question we did. To solve a question like this, we had to get the fraction by itself. And then I had to get rid of the denominator. I know a lot of folks want to Maywood special this and distribute here, but I find that isn't very helpful in a lot of circumstances, so I'm not going to do it here. So to get rid of the denominator, I just multiply by 5 on both sides, and I get 25 on the right. The denominator cancels over here, and I get 4 times x minus 1 plus 3. No fractions left, easy problem. Subtract 3, 22 equals 4 times x minus 1. Divide by 4. You get, whoops, I don't need parentheses anymore. X minus 1 equals 22 over 4. And then just add 1 to both sides. And I get x equals What is 22 over 4? Well, it's 11 over 2, or it's 5.5. And so the answer here would have been 6.5. Because 10 over 2 is 5, so 10 over 2 plus 1 over 2 is 5.5. And boom shakalaka, fraction problem, fraction answer. Okay, another type of fraction question is one more similar to the one on the warm-up today, like 2x minus 1 over 4 plus x minus 3 over 2 equals 2. And this is a style of question. So you have two options here. You can go the common denominators route, or skip that step and just multiply both sides by the common denominator. And so I'm going to try that trick now, since I did the common denominator way before. I multiply both sides by 4, because 4 is what gets rid of both of the denominators, and what my common denominator would be. If I multiply by 4, here it cancels that 4, and I just get 2x minus 1. In the second term, it cancels with this 2, but I get a 2 left over on top, so I get a plus 2 times x minus 3. And 4 times 2 is 8. So I distributed the 4 to each of these terms, and that was all the canceling and that sort of thing. Now that you've done this, no fractions left. You're in happy land. You can distribute the 2 in. 2x minus 1 plus 2x minus 6 equals 8. And let's see how horrible this answer is going to be. Oh, not that bad. Combine like terms. 4x minus 7 equals 8. Just combine the 2x and the 2x, and the negative 1 and the negative 6. I add 7 to both sides, and I get 15 equals 4x. And I divide by 4, and I get 3.75, or 15/4 for x. So these are the two types of fractiony questions that I put on that homework 1.3, which we assigned, mostly to get you thinking about solving equations again, because we're solving a lot of equations next chapter. Chapter 9 is a lot more algebra heavy than Chapter 8 was. Chapter 8 was like making pictures, knowing what pictures look like, writing equations. No real algebra in there. Chapter 9 is like all algebra, so that's why we're reviewing this. New questions on these? If you have any other specific questions, I'm happy to answer them, but I was going to move on to the third directive, which was show how to find the axis of symmetry and find the vertex. Cool. Here's the play. If you're just given any quadratic, here is a quadratic. It's a quadratic because there's a squared in the power. That's all that makes something a quadratic. To find the vertex here, we do the opposite of this, comma this. So negative 2, comma negative 17. Bam, vertex. Axis of symmetry, is very easy. It's always x equals the x coordinate of the vertex. And that's all you have to do for axis of symmetry. So if you know the vertex and you know the x coordinate of the vertex, you're good. Boom. Axis of symmetry is just x equals that. You didn't hear the first one? Is my mic low? Yes, I'll do another example. So, new example. 1/2 times x minus 14 squared plus 77. The vertex is the opposite of this, comma this, because our equation is always a times x minus h squared plus k. Did I write that too high? I think so. y equals a times x minus h squared plus k. And then we just look for what's here. Well, what's subtracted from x is 14. K is 77. Vertex found. And my axis of symmetry is x equals the x coordinate of the vertex. Bam. That is the game. So it's just pull the h and k out of the vertex form of the equation, vertex, and do x equals the x coordinate, and that's axis of symmetry. The skill we're going to be adding next unit is actually finding the x-intercepts, because right now we could find the y-intercept if we expanded this whole equation out. It's relatively janky. It's like 173. We could find this by expanding this, but that we don't know how to find the x-intercepts quite yet. Did you get that one, Caden? Slash, are there any other questions? Because I did 2 examples of all of the first round of questions. Sweet. Janky. It's not too bad, I swear. Like, here, going the... What is 173? Oh, sorry, that was the y-intercept. To go through what that 173 was, because I remember the last equation, I think. Was it 273? Yeah. Whoops. Sorry, Mr. Kennedy did bad math. It was 273. Anyways. That was pretty weak. Oh, Lord. Oh, no. No. Never mind. It was 175. It was still weak math. All right. Anyways, to get the y-intercept for this equation, we actually have the tools, and gosh darn it, I did it off the screen again. Okay, so fixed. To find the y-intercept, this is actually something we know how to do at this point. We'd have to expand the x minus 14. Like, meow. And you get x squared, negative 14x, negative 14x, and 196. And you get y equals 1/2 times x squared minus 28x, adding together the two negative 14s, plus 196 plus 77. And so all I did was the box method and expand x minus 14 squared. Next step, I distribute the half, and I get half x squared minus 14x plus 98 plus 77. And this number at the end, 98 plus 77, now that I've converted out of vertex form and into standard form, is my y-intercept. And that number is actually 175. And so 0, 175 would be my y-intercept. And that's actually something we know how to do and combines a few of our lessons. So, yeah, 173 was wrong. It was 175. Let's see. When it was on the homework, it was like f of x equals 4x squared plus 2x minus 8. It was always x equals 1 for the vertex and never anything else. 4x squared plus 2x minus 8. That's a hard question. How do we complete the square on this? Basically, you don't know how to find the vertex from an equation that looks like this. So they wouldn't ask you this yet. That's too hard. They might ask you for a y-intercept, and you'd be like, yo, y-int equals -8. Bam. For almost all the answers, it was x equals 1. That's actually kind of hilarious. Sorry for breathing into the mic. I'm a very expressive person, and so I breathe loudly. and talk loudly. I apologize. Yeah, we haven't learned how to actually find the vertex of equations yet. That aren't in vertex form. If it is in vertex form, like y equals x minus 2 squared plus 4, very easy for us. 2 comma 4 is our vertex. But if it's in y equals, if I expanded this out, x squared, whoops, I'm going too high again. Y equals x squared minus 4x plus 8, like this. This we would have to convert into vertex form to know where its vertex is. And that's a little more work to do. And that's something we actually learn how to do next unit. So we'll be doing that more 2 or 3 weeks from now, maybe 4 weeks from now. Kind of depends on how fast next unit goes. Now, next chapter is chapter 9 in our book, and we're spending most of our, like, at least a month on chapter 9, I think. So it's going to be a big deal. We're going to be going into May with that. If you're worried about a test coming, it's very, very hard for us to test you fairly and not, like, have people's tutors do their tests for them and stuff. So most likely, a lot of our tests are just going to be do your online homework. So that's pretty cool. We're pretty worried about that with the AP test. I don't know if there are enough tutors who are going to be available during that hour to take people's tests for them. That's illegal, by the way. Don't do that. So yeah, the converting from standard form to vertex form is too hard for us. Converting from vertex form to standard form, totally fine. Chillin', easy. All we do is the box method of expansion. It's only illegal if you get caught. No, that's not true. That's not how illegal things work. It's only, you're only in trouble if you get caught. Anything else I could help out with? Any other questions? Or are people okay? Anything else I can help you with for the homework for this week or anything like that? Since the calculus students have started invading because we're getting closer to 1 p.m. calculus stream time. Botchin hasn't started yet. Kai's chill. Caden's good. No regrets is good. You've lived a very virtuous life, or you're a sociopath if you have no regrets. So, seeing as how camp number 2 is more probable, feels bad. Alrighty. Well, on that note, bye bye. I'm going to sign out and see you tomorrow, calculus kids. But see you in 2 weeks or a week and a half in Algebra 1. Wow, sociopath. See ya. Alrighty, later, guys.